So let R are the set of real numbers. B the universal set. And A be given as -8,6. B be given as 5 to positive infinity. Find one A complement, and then 2 B complement, and then 3 find A minus B, and then 4 find B minus A. So we just want to see what this means now, and then how do we get them from the if you're given intervals. So I've picked this question from the tutorial sheet 1 for last year. Sheet 1 for last year. This is question 2B, the one we're doing now. From 11-20 tutorial sheet 1 for last year. Okay, so we are told that R is the set of real numbers is acting as the universal here. So it's a universal set that we have for sets A and B. And we said the set, you can only be asked to find the complement of a set if you are given the universal set. Okay, you can only be asked to find the complement of a set if you are given the universal set. So in this case, we want to find a complement. So a complement can also be described as the universal set R minus A. The universal set R minus A, which you can also describe as the universal set R intersection A complement. So you can describe this as R intersection A intersection A complement. Okay, so now so here I'll just give you the notations. So how do we find it then? Well, there are two options. I get the set A the way it is. So we're given A is equal to -8 to 6. And I want A complement. Since the universal is R, it means that the interval is from -infinity to positive infinity. So when getting A complement, you go to -infinity and write it as your first thing here. Please note that we never include infinite or -infinity on any set. Never include infinite or -infinity anywhere. So when looking for the complement, you start with the boundary of the universal, the -infinity, and then pick the first number of the set A, the left boundary. So I'll pick -8. Is it included in A or it's not included? If you see this, it means not included. What does not included mean? not a member, of the set. So it means that -8 is not a member of A. And if -8 is not a member of A, then it's a member of A complement. So include it in the complement. Union, you skip the piece -8 all the way up to 6. So now you pick 6. 6 is a member of A. It's included there. So this means included. Okay, a member of the set. So if it's a member of A, then it's not in the complement of A. Comma, the boundary of the inverse. Like that. That's the easiest way of getting the complement. If you want to get B complement, we have B running from 5 to infinity. Now we get the complement. It will be from -infinity. Why from -infinity? That's where the inverse starts from. All the way up to where B is starting from. B starting from 5. So all the way up to 5. 5 is a member of B. So we exclude it in the complement. We're supposed to start again at the end of 5, of B. But B is ending at infinity, where the inverse ends. So the B complement will just be that single interval there from -infinity to 5. Like that. And then when we go to part 3 now, we get A minus B. A minus B is also described as A intersection B complement. You get the intersection of A and B complement. Now A, we have A here. So we have -8 to 6 as our A intersection. B complement is -infinity to +5. Let's use the shortcuts. Yesterday we said, if you have an intersection in between and there are intervals, you check the numbers. The first entries. So you check -8 and -infinity. Which one is the largest? Which one is bigger than the other? The starting numbers, which one is bigger than the other? -8 is bigger than -infinity. So we pick -8 as a starting point for the intersection. And then between 6 and 5, which one is smaller than the other? 5 is smaller than 6. And so we pick like that. We pick 5 the way it appears here. You pick 5 the way it appears there. Okay, so this question, I'm doing it without involving a number line. And then we'll do another one where we'll just use the number line now, no shortcuts. So here we're using the shortcuts, no number line. Are we able to get the solution? They're coming out. Okay. For intersection, the left numbers, you pick the bigger one. The right numbers, you pick the small. The fourth one, B minus A, is also the same thing as B intersection A complement. B is 5 to positive infinity. Intersection A complement is negative infinity all the way up to negative 8. So I need space there. Let me do this one from down. Okay, so we have B 5 to infinity. Intersection A has two pieces, negative infinity to negative 8, union 6 to positive infinity. What is the intersection here? So you check. Remember, you must check. We have 5 and negative infinity. Which one is, because this is the intersection. So intersect this guy versus this one, and then union this guy versus the other one. So now 5 and negative infinity, you see that 5 is bigger than negative infinity. So we'll get 5 there. And then positive infinity and negative 8 is smaller than positive infinity. So we'll get negative 8 there.
Yeah.
Hello. Okay, so we get negative 8. Immediately after getting negative 8, you see that you are starting with 5 and ending with negative 8. It doesn't make sense for intervals. Intervals, they start with the smallest number to the bigger number. A must always be less than B for the interval. And then you can put it like that. But if it's the other way around, it means that's an empty set. So these two do not intersect. And that's how we know, if you're not using the number line, that these two do not intersect. So this doesn't exist, this part. Okay. So it means that for this interval and this one, there's no intersection. So we go straight to the intersection between this interval and the other one. So again, you have 5 and 6. You pick 6, which is bigger than 5. And then infinite and infinite, you pick the very infinite. So this will be the solution. How is it? Harrington?
I'm lost. Why are you using those brackets showing that they are not included?
On the solution?
Yes, the last part of the solution.
So this one, since they're getting the intersection, and they're saying for 5 and 6, we'll get 6, which is bigger than 5. And then 6 comes with this bracket here. So we pick 6 with its bracket. Yeah. And then infinite, We said you never include definite. Well, 6 is in this interval, yes, but it's not in this interval. An intersection means it must be in both. Okay, so now we'll do another question. And we're not going to use any of the methods we have used here. We'll use the number line throughout so that you can weigh which one will be working well for you. So we have this one that involves the shortcuts. Now we got the number line. Best.
Sorry to just to take people back.
Okay.
I don't understand this. Sorry to say brackets. Is this one for the one we have sharp corners in this one? So I want maybe you can just say something on this.
Okay.
Sorry, I'm behind.
Okay. So let's take notes. One, if I have set A equal to A, comma B, this means that A is a member. A is a member of set A. And then this one means that B is not a member of set A. So how do we use that? On the number line, you have A and then B. So you shade on A and leave an open hole on B. So you shade on A and leave an open hole on B. Then A complement is going to, because A is a member of B, then the complement will open, let me just write it like this. So this means that A is not a member of A complement. And this means that B is a member of a complement. So I've explained them in terms of how they are sitting in A and also how they respond to the complements. And then the second note, if A is equal to A comma B and B is equal to C comma D, A intersection B is going to be so what criteria are we using? We are saying for these two, pick a bigger number. And then for the other two, for the inside, here you pick the smaller one. For the intersection. So you pick the smaller one. And then for the first two, you pick the bigger number. If there's any intersection there. And then note number 3. A is equal to A comma B. It means that A is always less or equal to B. So the interval only makes sense if A is less or equal to B. So that part 4, if A is equal to 2, 2, this is empty. This is an empty set. Why is it an empty set? Because 2 is not included in the first bracket, and then it's included in the second bracket. So it's not making sense. So here I was trying out to explain the meaning of the brackets used and how you use them on the number line and how they respond to the complement. And for intersection, how do you pick using the shortcut? What about for union? A is equal to A comma B, and B is equal to C comma D. Then A union B, which is A comma B, union C comma D. How do we pick? From these two, you pick the smallest. And from the other two, you pick the largest. So you have your the union. So the union and the union and the intersection, that's the difference. For all the sets there. That is if you don't want to use the number line. So just want to do it the way we're doing it in this question here. So we're picking for intersection. We picked the smallest between, we picked the biggest between 5 and 6, and the smallest between infinite and infinite. Something happened here. We picked the biggest between these two and the smallest between these two. And the complement, because 8 was in, because -8 was not in A, it had to be in the complement. Because 6 was in A, it was not part of the complement. Because 5 is in B, it's not in the complement. That's how you use those brackets there. The true meaning being explained here. Okay, so we're using the Zoom, and Zoom cuts every 40 minutes. So it will cut, and then we rejoin so that we can do 2A of the same paper, so that now we can see how to use the number line to respond to such questions.